Hi students, I am D. Gopal, working as a SL in Kalam Junior College as a physics faculty. So I am going to explain today about thermodynamics and its importance in JEE mains. Mainly thermodynamics, not only in physics and also chemistry. So both in physics and chemistry can carry nearly 3 to 9% of weightage in the total. Okay, mainly on the physics, the thermodynamics. What do you mean by thermodynamics? So introduction about this thermodynamics. Thermodynamics is one of the branch in physics. It deals with mainly about how the quantity of heat supplied into essential or utilized into one. Okay, quantity of heat we can indicate it with either Q, capital Q or H, and work done should be denoted with W. What is the relation between this quantity of heat and work according to Joules law? So we start with that Joules law today. Okay, I will explain. Joules law and its importance. Joules law. So Joules law states that the amount of work done and quantity of heat supplied to the system is always directly proportional. W directly proportional to Q, or we can write it as W is equal to, with proportionality constant indicated with J, JQ. Here the J is called Joules constant or mechanical equivalent. J is equal to, we can write it as W by Q. Work done in MKS or SI system, the unit of work done is Joule. Quantity of heat, calorie. So Joule per calorie is the unit of Joules constant. Joule per calorie. What is the value of this proportionality constant? Is 4.19 or nearly 4.2 J per calorie. Joule per calorie. See about the joules. How the quantity of heat supplied should be converted into work. W directly proportional to Q, or W is equal to JQ, then J is equal to W by Q. So what is the value of J, either Joules constant or mechanical equivalent? The value of J is 4.18 or nearly 4.2. So while solving in problems, we can consider it as for our convenience it should be 4.8 joule per calorie. Okay. Next one. Okay. After completion of this Joules law, we can say about the first law of thermodynamics. First law of T. How can you define the first law? What is the mathematical expression for this first law of thermodynamics? First law. First law states that, like, consider a system consists a tight frictionless piston. Suppose if you supply heat to the system or some quantity of heat to the system, so the quantity of heat supplied to the system will be denoted with the dq. The quantity of heat supplied to the system, it can do two things. One is that due to this quantity of heat, internal energy, that means in between the molecules, there should be random collision. Internal energy of the system increases, and partly the quantity of heat supplied should be converted into work. That means dq is equal to du plus dw. Here du is the internal energy, dw is the work done. Here dw, there will be mainly two types of this work done. Suppose work is done on the piston, that means volume increases. Work is done on the piston by supplying heat. Work is done on this piston, that means suppose this piston is moving due to internal energy, rising of internal energy, piston moving upward, that means work done by supplying heat. Okay, that means if volume increases, we can consider it as positive. Suppose if you work is done on this piston, volume in the system will be decreases, then it should be considered as negative in front of this signs. Positive or negative work done, you should be differentiated as either work is done by the piston or work is done on the piston, depends upon those. Okay, this is the about first law of thermodynamics. Next, second law. Second law of thermodynamics. Second law of thermodynamics mainly contains two important statements. It's included. One is that Kelvin-Planck statement. Kelvin-Planck statement. Another one is the Clausius statement. So Kelvin-Planck statement, according to this statement, no heat engine or no device will be 100% efficient. That means whatever quantity of heat we are supplied to the system, it will not be completely converted into useful work. That is about this Kelvin-Planck statement. The second one, Clausius statement, states that heat cannot flow from cold body to hot body. Hot body to cold body, it can easily flow. There are three types of systems. We are already learned in the thermal properties. That means conduction, convection and radiation. That is from hot body to cold body. But heat cannot flow by itself from cold body to hot body without help of any external agency. సో అంటే ఎవరి సహాయం లేకుండా ఎట్టి పరిస్థితుల్లో కూడా కోల్డ్ బాడీ నుంచి అండ్ మీన్స్ లోయర్ టెంపరేచర్ నుంచి హై టెంపరేచర్కి హీట్ అనేది ఫ్లో అవటం అసాధ్యం, సిద్ధాసాధ్యం. నెక్స్ట్ one, after completion of these two laws, the important topic in this is how can you differentiate the process. Two process, important process are there. One is that isothermal and another one is adiabatic. What are the main important differences between this isothermal and adiabatic? On isothermal process work done we have problems, and on adiabatic also we have problems, how to solve the problems on adiabatic. So we can cover in the next periods. Okay, first one, isothermal process. So iso means, what is the meaning of iso? Temperature remains constant. Temperature remains constant throughout the entire process, but pressure and volume can be variable. Temperature must be constant. That means that is the meaning of iso. In isothermal process, the system, that means cylinder and as well as piston, are made with good conductors of heat. That means if temperature increases in the system than the surrounding, it can easily flow from system to surrounding. Otherwise, if surrounding has more temperature than the system, it can absorb the heat from the surroundings. That means there is a good thermal communication between the system and the surroundings in case of isothermal process. Okay, here they are made with, that means cylinder walls, that means cylinder as well as piston, they are made with good conductors of heat. Okay. Next, the work done. How can you calculate the work done in case of isothermal process? There is the formula nRT log base E of V2 by V1. This is the formula you need to find the work done in case of isothermal process. Here, number of moles is indicated with small n. R is universal gas constant. T is the temperature, final volume and initial volume. Ratio of final and initial. This is the formula used to find work done in case of isothermal process. Next one, adiabatic process. Adiabatic process. Here, in case of adiabatic process, cylinder as well as piston are made with bad conductors. Bad conductors means insulators. They do not allow the heat to flow. That means there is no thermal communication between the system and the surroundings. It is a quicker process than the isothermal process. Okay, in case of adiabatic process, pressure, volume and temperature, all the factors may be changed. But in case of isothermal, temperature throughout the entire process will be constant. Only pressure and volume will be changed. Okay, here they are made with bad conductors or insulators. There is no thermal communication between the system and surroundings. It is a quicker process than the isothermal process. So formula used to find ratio between pressure and volume in case of adiabatic process. P1 V1 power gamma is equal to P2 V2 power gamma. Here gamma, the adiabatic constant. Specific heat constant Cp by Cv. You can calculate this gamma by using the formula Cp by Cv. Specific heat at constant pressure to specific heat at a constant value. Okay. This is the relation to find either ratio in pressure or volume. P1 V1 power gamma is equal to P2 V2 power gamma in case of adiabatic process. Adiabatic process is a quicker process than the isothermal. Here pressure, volume and temperature all may be changes. But in isothermal, only pressure and volume may change. Temperature remains constant the entire process. Okay. What is the work done to find adiabatic process work done? W is equal to R by gamma minus 1 into T1 minus T2. The formula is to find work done in case of adiabatic process. Essential theories and concepts, foundations for thermodynamics. Here they are given the definition for thermodynamics. Thermodynamics is the branch of physics, relation between heat and work, temperature, energy. Explain how. That means in how many ways the heat energy will be transfers into work. Okay. calculating the efficiency of missions. That means the important one is Carnot engine efficiency. How do we have to calculate the Carnot engine efficiency in this chapter? That is the important topic. It can also carry 1 or 2 marks, 2 blanks from that topic. So next one. So first law, second law, then the another law. This is also one more law, zeroth law. See here, zeroth law statement. Next, temperature measurement. On the basis of temperature measurement, on the basis of zeroth law, we have 2 scales in the thermal properties of matter we have studied, Celsius and Fahrenheit, as well as Kelvin. How to convert Celsius to Fahrenheit or Fahrenheit to Celsius to Kelvin. That also considered as some of the blanks on the topics. Okay, next one. We can next we can discuss about next one. We can discuss about how do you calculate the specific gas constant. So let's say indicated with gamma. Already said that it is the ratio of specific heat capacity at constant pressure to constant volume. There are 3 types of gases according to our syllabus. The first one is monoatomic gas, degrees of freedom 3. Next, diatomic gas, degrees of freedom 5. Next, polyatomic or triatomic gas has degrees of freedom 6. Then how do you calculate the value of Cp and Cv? And finally we can find the ratio between the Cp and Cv. And finally we get the specific gas constant gamma. Okay? So first of all, specific heat at constant pressure, Cp is equal to F by 2 plus 1 into R. Here, F indicates degrees of freedom. What do you mean by this degrees of freedom? According to the definition, number of possible motions of the particle can undergo. What are the types of motions? We know that translational motion, rotatory motion, vibratory motion, random motion, oscillatory, like that so many motions.